All right, let's dive in. Today, we're going to talk about a secret your body's been keeping your entire life. It's true age. And you might be surprised to find out it's not what you think it is.
We've all heard that saying, age is just a number. But what if it was literally true? What if the number of candles on your birthday cake was just one part of a much bigger, much more interesting story?
So here's the thing. You've actually got two different ages. First, there's your chronological age. That's the easy one, right? It's how many years you've been on the planet. It's kind of like a car's model year. But then there's your biological age. Yeah, that's the mileage. That's the real wear and tear on your body's systems. This means two people could both be 40, but one might have the biology of a 30-year-old, and the other, maybe a 50-year-old. Okay, so if we have this hidden age, this internal mileage, how in the world do we actually measure it? Well, that's the very question that's fascinated scientists for years.
You see, the big challenge was always finding a reliable biomarker. I mean, something you can actually measure that gives you a real, honest look at your biological state. They needed something that could track the aging process consistently and accurately across your whole body, not just one little piece of it. And that search, it led to something absolutely groundbreaking. Not a clock with gears and hands, but one that's been ticking away inside of us, written into our very DNA this whole time. It's called the epigenetic clock. Now, that word epigenetic sounds complicated, but the idea is actually pretty simple. It just means on top of your genes. So we're not talking about changes to your genetic code, but changes in how your body decides to read that code. And it turns out these changes happen in a pattern that is surprisingly predictable. So, how does this thing actually work? Well, imagine your DNA is this giant instruction manual for your body. Now, as you go through life, your body adds these tiny chemical tags. They're called methyl groups to the pages. The best way to think of them is like little sticky notes. They don't rewrite the instructions, but they can cover up a word here or highlight a sentence there, changing how the manual gets read. And here's the key. Scientists found that the pattern of where these sticky notes are placed changes in a really predictable way as we get older.
Okay, so the body is putting these little sticky notes on our DNA. Cool. But it took a real stroke of genius to figure out how to read those notes and turn them into a powerful predictive tool.
So, jump to 2013. A UCLA professor, Steve Horvath, has this massive breakthrough. He sifted through thousands of DNA samples and pinpointed exactly 353 of these sticky notes, these methylation sites, that were the absolute best indicators of age. By just looking at the pattern on those 353 spots, he created a single test, a single clock, that was astonishingly accurate. And the best part? It worked on almost any tissue in the human body. And when I say accurate, I mean shockingly accurate. This number, 0.96, is the statistical correlation between the clock's guess and a person's actual age. See, in statistics, a score of 1.0 is a perfect match. So getting a 0.96, that's almost unheard of. It's incredibly precise. And to really get how big of a deal this was, you just have to look at what came before. For a long time, scientists looked at something called telomere length, those little protective caps on our chromosomes. They get shorter as we age, sure, but as you can see, the data is, well, it's all over the place. It's what scientists call a noisy signal. Horvath's clock, on the other hand, it's crystal clear. Okay, so we have this super accurate clock. That's cool, but what it can actually tell us about our bodies and our lives, that's where things get really wild. First off, get this, not all parts of your body are the same age. No, really. The clock revealed that some of our tissues age way slower than others. For example, in people who live past 100, the cerebellum, that's a part of the brain, is often biologically 15 years younger than the rest of their body. The clock can also pick up on major life events. Studies have shown that menopause, with all the hormonal shifts that come with it, actually speeds up a woman's epigenetic aging rate. You can literally see it on the clock. And hey, it looks like good aging might actually run in the family. Turns out the children of supercentenarians, we're talking people who live to be over 105, are, on average, biologically about 5 years younger than other people their same age. It also shows the heavy toll that chronic illness can take. For example, an HIV infection has been shown to speed up the biological age of blood tissue by more than 5 years. It's a stark reminder of the deep cellular stress these diseases cause. But here's the most important part. This isn't all just about genetics or things that happen to you. The choices you make matter a lot. As you can see here, things like eating a healthy diet, getting physical activity, even education, they're all linked to a slower biological clock. On the flip side, things like obesity and high alcohol consumption are linked to hitting the fast forward button. Our lifestyle is literally being written onto our DNA.
Which, of course, brings us to the million-dollar question. If we can measure our biological age and we know our lifestyle can change it, can we actually slow down time? Or maybe even turn it back? And the potential applications here are just mind-blowing. This is way more than a curiosity. We're talking about using these clocks to predict if someone is at risk for diseases like cancer or Alzheimer's. We could use them to test if a new health therapy is actually making people younger. It could even be used in forensics to figure out a suspect's age from a tiny drop of blood left at a crime scene.
So why? Why does this clock even exist in the first place? Is it some kind of built-in self-destruct timer? Well, the leading theory says no, not at all. It suggests that these epigenetic changes are really just the footprints, the unintended consequences of all the essential work our body does every single day to grow, to function, and to repair itself. In other words, aging isn't the program. It's just a byproduct of living.
And that brings everything right back to you. This science is moving at lightning speed, and pretty soon, knowing your biological age could be as normal as getting a checkup. So I'll leave you with this question, and it's a personal one. If you could know your body's true, secret age, would you really want to?